Our planet has a long and dramatic history. It's a story written in rock, ice, and the fossil record. And it's a story that's been profoundly shaped by asteroid impacts. These cosmic collisions, ranging from tiny dust particles to mountain-sized behemoths, have left their mark on Earth since its formation. Asteroids are remnants from the early solar system, leftover building blocks that never coalesced into planets. They roam through space, sometimes crossing paths with Earth, while most burn up in our atmosphere as harmless shooting stars. Some make it through, delivering a powerful cosmic punch. These impacts have played a crucial role in Earth's evolution. They've delivered water and organic molecules, the building blocks of life. They've triggered volcanic eruptions and earthquakes, reshaping continents. And they've caused mass extinctions, wiping the slate clean for new life to evolve. Understanding asteroid impacts is crucial for understanding our planet's history. It's also essential for our future as we learn to predict and potentially deflect these cosmic threats. Space is not empty. It's teeming with asteroids of all shapes and sizes. Earth is constantly bombarded by these space rocks, though most are too small to pose a threat. Every day, tons of dust and small meteoroids, some no bigger than a grain of sand, enter Earth's atmosphere. They burn up due to friction, creating fiery streaks across the sky, shooting stars. Larger objects, like those the size of a car, enter the atmosphere a few times a year. These usually explode in the air, creating a bright fireball and sometimes scattering meteorites on the ground. Impacts from larger asteroids, those capable of causing significant damage, are much rarer. An impact from an object the size of a football field occurs every few thousand years. These can cause regional devastation. Catastrophic impacts like the one that wiped out the dinosaurs are thankfully extremely rare. These involve asteroids several miles across and occur on timescales of millions of years. While the frequency of large impacts is low, the consequences can be enormous. Therefore, understanding these events and developing strategies to mitigate their risks is crucial for humanity's long-term survival. The Earth bears the scars of countless asteroid impacts throughout its history. Some of these scars are obvious, like massive craters that dominate the landscape. Others are more subtle, hidden beneath layers of sediment or buried under the ocean floor. One of the most striking pieces of evidence is the impact craters themselves. These circular depressions, often surrounded by a ring of mountains, mark the spots where asteroids slammed into Earth. Some of these craters are remarkably well preserved, offering scientists a glimpse into the past. Other evidence comes from the rocks themselves. The intense heat and pressure of an impact can create unique minerals and rock formations. For example, shocked quartz, a form of quartz with a deformed crystal structure, is a telltale sign of an impact event. By studying these craters, minerals, and rock formations, scientists can piece together the history of asteroid impacts on Earth. They can estimate the size and speed of the impact, the date of the event, and the effects on the environment and life on Earth. Section 4. Cosmic Close Calls, Chelyabinsk and Tunguska. While catastrophic asteroid impacts are rare, recent history reminds us that Earth is still vulnerable to these cosmic events. Two notable events in the 20th and 21st centuries serve as stark reminders of the potential danger posed by even relatively small asteroids. In 1908, a massive explosion rocked the Tunguska region of Siberia. The blast, estimated to be about 1,000 times more powerful than the atomic bomb dropped on Hiroshima, flattened trees over an area of 2,000 square kilometers. The cause? An asteroid, perhaps about 50 meters across, that exploded in the atmosphere. More recently, in 2013, an asteroid about 20 meters in diameter entered the atmosphere over Chelyabinsk, Russia. The asteroid exploded in the air, generating a shock wave that shattered windows and injured over 1,000 people. These events highlight the unpredictable nature of asteroid impacts. They also underscore the importance of early detection and developing strategies to deflect or mitigate the effects of these cosmic threats. Section 5. The dinosaur killer Chicxulub impact. 66 million years ago, a cataclysmic event changed life on Earth. An asteroid, about 10 kilometers wide, slammed into the Yucatan Peninsula. This impact triggered global disasters, leading to the extinction of the dinosaurs. The immediate effects were catastrophic. The explosion released energy equivalent to billions of atomic bombs. It ignited wildfires, triggered earthquakes and tsunamis, and sent dust into the atmosphere. The long-term effects were devastating. Dust blocked the sun, causing darkness and cold. This impact winter disrupted plant life, collapsing food chains. The Chicxulub impact is a reminder of the destructive power of asteroids. It highlights the interconnectedness of Earth's systems and the impact of a single event. Section 6. Other significant impacts and their echoes. The Chicxulub impact is the most well-known example of an asteroid impact shaping Earth's history, but it's far from the only one. Numerous other impact events have left their mark on our planet, shaping its geology, climate, and the evolution of life. One such impact, about 2 billion years ago, created the Vredefort crater in South Africa. This massive crater, about 300 kilometers across, is the largest impact structure on Earth. The impact is thought to have triggered a global ice age and may have played a role in the evolution of early life. Another significant impact created the Sudbury Basin in Canada, the second largest impact structure on Earth. This impact, which occurred about 1.85 billion years ago, released vast amounts of nickel and copper into the surrounding area, creating one of the world's richest mining regions. These impacts, along with countless others, highlight the ongoing role of asteroids in shaping Earth's history. They also remind us that our planet is not immune to these cosmic events and that understanding them is crucial for our long-term survival. Section 7. Guardians of Earth, NASA's planetary defense. The threat of asteroid impacts is real, but it's a threat we can prepare for. NASA and other space agencies are engaged in planetary defense to detect, track, and deflect hazardous asteroids. The first step is detection using ground-based and space-based telescopes. Once detected, the object's orbit is calculated to assess impact risk. If hazardous, strategies like deflection or disruption are developed. Planetary defense requires international cooperation and innovation. As we explore space, we learn to protect Earth from cosmic threats.